Recently, our client John met his banker to discuss plans for a clean energy building. What he found was a shared passion for building something more. Momentum for change. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. This morning in North Carolina, wheels are spinning. Determination is winning. A passion is now a thriving business, and it shows no signs of slowing down. How? The power of a conversation, like the one Clint Spiegel had with First Horizon Bank about starting a bike wheel manufacturing facility in Asheville. Now it's not just talk, it's rubber meets road. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Clint. First Horizon Bank, member FDIC.
This is SpaceTime, Series 26, Episode 81, for broadcast on the 7th of July, 2023. Coming up on SpaceTime, discovery of a white dwarf pulsar shedding new light on stellar evolution, a new study looking at how quickly planets form, and Virgin Galactic undertakes its first commercial flight. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The discovery of a rare type of white dwarf star system is providing a new understanding of stellar evolution. White dwarfs are small, dense stars, typically the size of a planet. They're formed when low-mass stars like our Sun run out of nuclear fuel in their core. This causes the star's outer envelope to expand and eventually puff off as a planetary nebula. What's left behind is the exposed white-hot stellar core, a white dwarf, which will then slowly cool over the eons. Now, a rare type of white dwarf, called a white dwarf pulsar, has been discovered for only the second time ever, the first being AR Scorpii back in 2016. White dwarf pulsars include a rapidly spinning white dwarf, which is lashing its neighbour, a red dwarf star, with powerful beams of electrical particles and radiation, causing the entire system to brighten and fade dramatically over regular intervals, just like the beacon of a lighthouse. Now, we know the pulsar is caused by strong magnetic fields, but scientists aren't sure what's causing those. One key theory to explain the strong magnetic field is the dynamo model. That involves white dwarfs having dynamos, that is, electric and magnetic generators in their cores, similar to that of the Earth, but much more powerful. But for this hypothesis to be tested, scientists needed to search for other white dwarf pulsars to see if their prediction held true. Now a report in the journal Nature Astronomy describes a newly detected white dwarf pulsar catalogued as J191213.72 minus 441045.1. Located 773 light-years from Earth and spinning around 300 times faster than the Earth does, the white dwarf pulsar is about the same size as the Earth, but packing as much mass as the Sun. Now, in simple terms, it means a teaspoon of white dwarf material would weigh about 15 tons. White dwarfs begin their lives at extremely hot temperatures, but gradually cool down over billions of years, and the low temperature of this particular white dwarf pulsar points to an advanced age. One of the study's authors, Ingrid Pellisolli from the University of Warwick, says the origins of magnetic fields remains a big open question in many areas of astronomy, and this is particularly true for white dwarfs. See, the magnetic field of a white dwarf can be 1,000,000 times stronger than the magnetic field of the Sun, and the dynamo model would help to explain why. The authors scanned through stellar survey data, looking for star systems with similar characteristics to AR Scorpii. And they then followed up any candidates with UltraCam, which can detect the very fast light variations expected from a white dwarf pulsar. After observing a couple of dozen candidates, they finally found one that showed very similar light variations. The follow-up campaign using other telescopes revealed that roughly every 5 minutes or so, the system sent out a radio and X-ray signal in our direction. It confirmed that there are more white dwarf pulsars out there. And there were other predictions made by the dynamo model which were confirmed by this discovery. See, due to their old age, white dwarfs in a pulsar system should be cool. Their companion should be close enough that the gravitational pull of the white dwarf was in the past strong enough to capture mass from the companion, and this causes them to be spinning fast. And all of these predictions hold for the new pulsar found. The white dwarf is cooler than 1300 Kelvin, spins on its axis every 5 minutes, and the gravitational pull of the white dwarf has a strong effect on the companion. This is SpaceTime. Still to come, a new study looks at how quickly planets form, and Virgin Galactic undertakes its first commercial flight. All that and more still to come on SpaceTime. Astronomers have discovered that planets can take less than 1 million years to form. The findings, reported in the Astrophysical Journal, follow a major survey of protoplanets seen forming in the protoplanetary disks around young stars. These protoplanets were already well underway in their formation process, and the study's authors wanted to determine exactly how early after a star is born do the first planets begin to form within the system. See, these protoplanetary disks only last a few million years, meaning that the forming planetary system really only has this amount of time to finish its formation. However, it's still not clear just how rapidly planet formation begins within these disks. Recent observations have revealed many protoplanetary disks have structures inside them like gaps and rings, indicating that planets are already forming in these disks. So, if these protoplanetary disks already had planets forming in them, the authors would need to look earlier in the protostellar disk from which the newborn star had just emerged. Using ALMA, the Atacama Large Millimeter Submillimeter Array Radio Telescope in Chile, the authors studied protostars with a very high resolution in order to search for the earliest signs of planetary formation. They observed disks around 19 protostars, all located within 650 light-years of the Earth. Now, this in itself was the first systematic study to investigate the detailed structure of disks around a large sample of protostars with high angular resolution. The observations clearly showed that the protostellar disks around protostars are different from the more evolved protoplanetary disks. Among the 19 protostars, rings and gaps, which are signs of planetary formation, were observed in only a few of the disks, and the ring structures and gaps were far less distinct than those seen in protoplanetary disks. The authors didn't expect to see such clear differences between the disks around protostars and more evolved disks. The results suggest that the disks around protostars simply aren't fully ready yet for planetary formation. And that suggests that planetary formation in a planetary system progresses rapidly in the 100,000 to 1 million years after the star formation process begins. This is SpaceTime. Still to come, Virgin Galactic undertakes its first commercial flight, and the spectacular Southern Cross, the constellation Leo, and the red supergiant Antares are among the many highlights of the July night skies on Skywatch. Virgin Galactic has successfully undertaken its first commercial suborbital flight, carrying a crew from the Italian Airforce and the nation's National Research Council to the very edge of space. The landmark event, almost 20 years in the making, marks the start of the company's space tourism operations. The historic flight aboard Spaceship Two VSS Unity lifted off from a conventional runway at Spaceport America in New Mexico, attached between the twin fuselages of the White Knight II mothership Eve.
Pilots are ensuring the spaceship is in the launch configuration after going through the various L-10 checks, confirming that all the settings are go for launch. This is also when Spaceship Unity will isolate the air supply from Eve and prime the rocket motor by opening the backup oxidizer valve. Once these actions are complete, the pilots will seek clearance from the MCC, that's shorthand for the Mission Control Center, for release.
After climbing to an altitude of approximately 44,500 feet, that's roughly 15,000 meters, Unity was released and ignited its hybrid rocket engine to quickly accelerate vertically through the sound barrier towards the blackness of space.
3, 2, 1, release, release, release. Ignition. Good control. Trimming, that's pulling the nose up. After release, the crew lights the rocket motor, and Unity's trajectory to space begins in that horizontal release position before turning towards space, a maneuver we call the gamma turn. The rest of the rocket motor burn will occur in the vertical, and everything after release through the completion of the rocket motor burn is called boost. The trim is complete and Unity is in the vertical headed toward space. And trim is set. We're now traveling at approximately Mach 1.4. There's max Q, that's the maximum dynamic pressure on the vehicle. Those on board are experiencing about 3 Gs at the moment. Mach 2, rocket motor cutoff.
Main engine cutoff ending the boost phase of the mission ended at Mach 2.8.
After boost is feather. Now, sometimes when we say feather, we mean the tails of the spaceship, and sometimes we're referring to moving these tails into what we call the feathered configuration. So, due to the law of conservation of momentum, feathering the vehicle, that's rotating the tails to 60 degrees, causes the cabin of Unity to start a backflip maneuver as it approaches our next phase, apogee. And this backflip is a key part of the experience because it maximizes the view of the Earth below. Our pilots use the RCS, that's a reaction control system, to hold the spaceship in that attitude.
Suborbital apogee was achieved just 58 minutes after launch at an altitude of 85.1 kilometers, just 15 kilometers short of the Kármán line, marking the official start of space.
Our mission specialists have been cleared to unstrap and enjoy the zero-G experience.
Colonel Villaday going to the back to tend to the payloads that are mounted on the rack. Landolfi and Leo starting their experiments in their seat.
The feather is moving, starting that backflip maneuver I spoke of. The feather is now fully up.
And viva la Italia! This is 100 years for the Italian Airforce, so happy centennial to the Air Force. This is absolutely incredible, and welcome to space, astronauts. Benvenuto nello spazio. Congratulations to Walter, Angelo, and Leo on becoming astronauts today.
We have achieved apogee at 279,000 feet.
After undertaking a series of microgravity experiments, and of course enjoying the spectacular views of the Earth beneath, Unity began its descent back to the surface.
Pilots are currently completing the backflip maneuver, orienting the vehicle for re-entry. You know, when we talk about space travel, a lot of people know and they expect the boost portion of flight to be loud and thrilling, and of course it is. But what's interesting is that the re-entry is actually very similar. So as supersonic air flowing over our vehicle in the feathered configuration, shock waves form on top of the cabin, and those are audible to those inside. And then at the right time, the pilots will again use the RCS to continue that backflip all the way around. This prepares the vehicle for re-entry. In the feathered configuration, the vehicle presents a large area of the wing to the atmosphere, allowing our system to burn off energy while still high in the thin atmosphere. And then after re-entry, the feather is once again lowered and locked, turning Unity into a glider. It's in this configuration that the pilots will fly back to Spaceport America in what we refer to as the glide phase.
Gliding to a conventional runway landing on the same tarmac it had taken off from 90 minutes earlier. The Italian government had paid roughly $680,000 for each of the passengers on the flight. British entrepreneur Richard Branson founded Virgin Galactic back in 2004 in the aftermath of the success of scaled composite Spaceship One wing spaceplane, which had just won the X Prize by becoming the first privately built and operated spacecraft to reach space twice within the space of 2 weeks, thereby proving that regular space travel is possible. Virgin Galactic's fleet of suborbital rocket planes, known as Spaceship Twos, are all based on the original Spaceship One design. This is SpaceTime.
Recently, our client John met his banker to discuss plans for a clean energy building. What he found was a shared passion for building something more. Momentum for change. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. Tonight in Arkansas, there's a mother tucking in her daughter and turning off the light. A business owner is burning the midnight oil. An at-home dinner date is plating up possibility. And it's all happening under one roof. How? The power of a conversation, like the one John from Integrity Solutions had with First Horizon Bank about his vision for a sustainable mixed-use building. Now it's not just words, it's life. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. First Horizon Bank, member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
And time now to turn our eyes to the skies and check out the celestial sphere for July on Skywatch. July is the 7th month of the year in both the Julian and Gregorian calendars, and is named after the Roman Emperor Julius Caesar, who was born during the month. Before being called July, the month was called Quintilis, which is Latin for 5th. The addition of the months January and February brought an end to that. On average, July is the coldest month in the year in the southern hemisphere, which is experiencing winter, and also marks the time when Earth is at aphelion, its furthest orbital position from the Sun. Of course, temperatures, or more accurately seasons on Earth, aren't dictated by the distance from the Sun, but rather the length of a day, and hence the amount of sunlight a given part of the Earth receives, which is governed by the tilt of Earth's axis. Consequently, that's why July is on average the warmest month in the northern hemisphere, which is currently experiencing summer. During this aphelion, Earth will be 152,093,251 kilometres from the Sun. That's about 5 million kilometres further away than during perihelion back on January the 5th, when it was 147,098,925 million kilometres away from the Sun. This year's aphelion occurred at 6:06 in the morning of Friday, July the 7th, Australian Eastern Standard Time. That's 4:06 in the afternoon of July the 6th, US Eastern Daylight Time, and 20:06 in the evening, Greenwich Mean Time. Over cosmic time, these dates change. That's due to variations in Earth's orbit, such as eccentricity, as well as axial tilt and precession, which all follow regular cyclic patterns known as Milankovitch cycles. Eccentricity involves changes in how elliptical Earth's orbit is around the Sun. None of the planets actually orbit the Sun in perfect circles, although Venus and Neptune are the closest. Instead, they all have elongated orbits which vary over time. As well as that, Earth spins on an axis which is currently tilted at 23.4 degrees compared to the ecliptic, Earth's orbital plane around the Sun. But this angle of tilt also changes over time, influenced by, among other things, the distribution of the Earth's mass. And just like a spinning top, the rotational axis of the Earth also changes its orientation through a process called precession, changing its position in relation to fixed background stars over a 26,000-year cycle. Now, all these effects impact the amount of solar radiation reaching the Earth, what time it reaches the Earth, and consequently the planet's seasonal and climatic patterns. Right now, the Southern Cross is at its highest point in the southern sky, and is pointing directly towards the southern celestial pole. The Southern Cross falls within the constellation Centaurus the Centaur, the half-human, half-horse of Greek mythology, and the creature is holding a bow loaded with an arrow. The Centaur's front legs are marked by the two pointer stars, Alpha and Beta Centaurus. At 4.3 light-years, Alpha Centauri is the second of the two pointer stars from the Southern Cross and is also the nearest star system to the Sun. The Centaur's back arches over the Southern Cross, and just above this is Omega Centauri, a spectacular globular cluster, visible with the unaided eye from dark locations. Globular clusters are tightly packed spheres containing thousands to millions of stars. They're thought to have all originally been born at the same time from the same molecular gas and dust cloud, or they're the cause of small galaxies which have been consumed by bigger galaxies through galactic cannibalism. Omega Centauri is about 16,000 light-years away. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Omega Centauri is one of the largest and brightest of the 150 or so globular clusters known to orbit around our Milky Way galaxy. Centaurus was one of the 48 constellations listed by the 2nd century astronomer Ptolemy, and it remains one of the 88 modern-day constellations. Turning to the right or west, and you'll see the constellation Leo the Lion, just above the western horizon. Its brightest star is Regulus, or the Little King, located about 79 light-years away. Regulus, designated Alpha Leonis, is actually a 5-star system, organized into 2 pairs. Regulus A is a spectroscopic binary, comprising a spectral type B blue-white main sequence star, some 4 times the mass and 288 times the luminosity of the Sun, and a faint companion star thought to be a white dwarf, the stellar corpse of a Sun-like star. Spectroscopic binaries are stars that can't be resolved by optical telescopes into 2 separate objects, and can only be separated by observing their individual spectroscopic Doppler shifts as they orbit each other. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive known stars are spectral type M red dwarf stars. Each spectral classification is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. So put all that together, and our Sun is a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which can be about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which can be 75 to 80 times the mass of Jupiter, or 0.08 solar masses. Located further away are Regulus B, C and D, which are dim main sequence stars. At the opposite end of the constellation from Regulus is the star Beta Leonis, or Denebola, the horse's tail. It's also a luminous blue-white star, about half as bright as Regulus, and the 3rd brightest star in the constellation Leo. Beta Leonis has about 1.8 times the Sun's mass and about 15 times the Sun's luminosity. It's suspected of being a dwarf Cepheid or Delta Scuti type variable star, meaning its luminosity varies slightly over a period of several hours due to pulsations on its surface. Algebra or Gamma Leonis is a binary system with a visible 3rd component. The 2 primary stars are located about 126 light-years away and can be resolved in small backyard telescopes. Both are yellow giants orbiting each other every 600 Earth days. The unrelated tertiary star named 40 Leonis is a yellow tinge star that can be seen through binoculars. The star's traditional name Algebra means forehead. Delta Leonis or Zosma is a blue-white star 58 light-years from Earth. Epsilon Leonis is a yellow giant some 251 light-years from Earth. And Zeta Leonis is an optical triple star. The brightest component is a white giant about 260 light-years from Earth, while the second brightest star, 39 Leonis, is widely spaced and located to the south of the primary. The 3rd and faintest star in the system, 35 Leonis, is to the north. Lota Leonis is a binary star system visible in medium-sized backyard telescopes. Located some 79 light-years away, Lota Leonis appears to be a yellow tinge star with 2 components orbiting each other every 183 Earth years. Finally in Leo, let's look at Tau Leonis. Visible as a double star through binoculars, it includes a yellow giant located some 621 light-years from Earth, and binary secondary star 54 Leonis, which is actually a pair of blue-white stars that are visible in small telescopes and located some 289 light-years away. The constellation Leo also contains many galaxies, including the spiral galaxy Messier 66, as well as Messier 65 and NGC 3628, which are known as the Leo triplet. Located some 37 million light-years away, the Leo triplet has a somewhat distorted shape due to gravitational interactions between Messier 66 and the other two galaxies, which are cannibalizing stars from Messier 66. Eventually, the outermost stars may well form a dwarf galaxy orbiting M66. Both M65 and M66 are visible in large binoculars or small backyard telescopes, but their concentrated nuclei and elongation are only visible in larger instruments. Other bright, well-known deep sky galaxies in Leo include Messier 95, Messier 96, and Messier 105. Messier 95 and Messier 96 are both spiral galaxies, each about 20 million light-years from Earth. Both look like fuzzy objects in small telescopes, but display their spectacular structures in larger instruments. M95 is a barred spiral. Another barred spiral, NGC 2903, is thought to be similar in size and structure to our own Milky Way galaxy. It was discovered by William Herschel in 1784. Close to the M95-M96 pair is the elliptical galaxy M105, which is also about 20 million light-years away. The constellation also contains the Leo Ring, a cloud of hydrogen and helium gas orbiting two of the galaxies in the constellation. A gravitationally lensed object known as the cosmic horseshoe is also found in Leo. Above Leo, you'll find the constellation Virgo, the Greek and Roman goddess of wheat and agriculture. Virgo's brightest star, Spica, is visible above the western horizon. It's located some 250 light-years away. Spica is Latin for ear of wheat, which Virgo is holding in a hand. Spica, or Alpha Virginis, is the 16th brightest star in the night sky, and is both a spectroscopic binary and a rotating ellipsoidal variable, a close binary system whose stars are not eclipsing but cause apparent fluctuations in brightness because of changes in the amount of light emitting area visible to the observer. Spica's two main stars orbit each other once every 4 Earth days and are so close they're egg-shaped rather than spherical and can only be separated by their spectra. The primary is the blue giant variable Beta Cepheid star. It undergoes small rapid variations in brightness. These are caused by pulsations of the star's surface, thought to be caused by the unusual properties of iron at temperatures of 200,000 degrees in the stellar interior. It has about 10 times the Sun's mass, and about 7 times its diameter. The secondary star in Spica is smaller than the primary, but it's still some 7 times more massive than the Sun, and has 3.6 times the Sun's diameter. Turning to the north now, and the constellation Boötes, the herdsman or ploughman. There you'll see the bright orange-red star Arcturus, or Alpha Boötes, just above the northern horizon. It's a red giant located just 36 light-years away, a bloated, aging star some 7.1 billion years old, nearing the end of its life. Although not much more massive than the Sun, it's now expanded out to some 25 times the Sun's diameter, and will soon puff off its outer gaseous envelope as a planetary nebula, revealing its white-hot stellar core, a white dwarf, which will then slowly cool over the eons of time. Another bright reddish-looking star, this time in the east, is the red supergiant Antares, meaning the rival of Mars, because of its appearance and location in the sky, which appears to be opposite of Mars in the sky. Antares is one of the biggest known stars in the universe. It's enormous, 18 times the Sun's mass, 10,000 times its luminosity, and 883 times the Sun's radius. As we mentioned in last month's Skywatch, were it placed at the centre of our solar system, its surface would extend out close to the orbit of Jupiter. Despite being some 550 light-years away, Antares is still the 15th brightest star in the night sky. Unlike the Sun or Arcturus, the death of Antares will be far more spectacular. Antares is destined to explode as a core collapse or Type II supernova. When it does so, sometime in the next few 100,000 years, it'll appear as bright in the Earth's sky as the full moon, and be quite visible even in daytime. Antares has a companion star, Antares B, a spectral type blue-white main sequence star, more than 7 times the Sun's mass and 5 times its diameter. Antares is the heart of the Scorpion in the constellation Scorpius. Below Scorpius is the constellation Sagittarius, the Archer, which points the way to the centre of the Milky Way galaxy. Sagittarius is commonly represented as a winged centaur, pulling back on a bow which is aimed at Arcturus. The centre of the Milky Way galaxy and its supermassive black hole Sagittarius A star lie at the westernmost part of Sagittarius. Sagittarius A star is about 27,000 light-years away and has some 4.3 million times the mass of our Sun. It was in July back in 2016 that the solar system's barycenter moved outside the Sun, where it will remain until 2027. A barycenter is the gravitational center of mass of a celestial system. For example, in our Earth-Moon system, the Earth and Moon actually orbit each other around a common center of gravity, a barycenter. Now, because the Earth is so much more massive than the Moon, the barycenter is always inside the Earth's radius. If it were outside the Earth's radius, the Earth and Moon would instead have been classified as a binary planetary system, like Pluto and Charon. The solar system's center of gravity, or barycenter, is usually located inside the Sun's radius. After all, the Sun contains over 99% of all the solar system's mass. But actually, the mass of the solar system is orbiting around the solar system's barycenter, which means the Sun also has a very slight spiraling 12-year orbit around the barycenter. And every now and then, when the planet's orbital positions are just right, especially when Jupiter and Saturn are nearest each other, their combined gravitational interactions move the solar system's barycenter ever so slightly outside the Sun's radius. And because Jupiter and Saturn reach this alignment every 11 years, some scientists have speculated whether this could trigger the Sun's 11-year solar cycle. And before you ask, the barycenter isn't named after some guy in a beige safari suit called Barry, but rather it's the ancient Greek word for heavy or center of mass. We also have 2 meteor showers, both of which peak in late July. There's the southern Delta Aquarids, which are visible from mid-July to mid-August each year, with peak activity on July the 28th and 29th. The shower originated either from the breakup of what are now the Marsden and Crack sun-grazing comets, or from the parent comet P96 Malkolts. The Delta Aquarids get their name because their radiant appears to lie in the constellation Aquarius, near one of the constellation's brightest stars, Delta Aquarii. There are 2 branches to the Delta Aquarids meteor shower, the southern and northern. The southern Delta Aquarids are considered a strong shower, with an average between 15 and 20 meteors an hour between midnight and dawn. Listeners in the southern hemisphere usually get the better show because the radiant is higher in the southern sky. Since the radiant is above the southern horizon for northern hemisphere listeners, meteors will be seen to fan out in all directions east, north and west, with few meteors heading southwards, unless they're really short near the radiant. The northern Delta Aquarids are the weaker shower, peaking later in mid-August, with an average peak rate of about 10 meteors per hour. Meanwhile, the nearby slow and bright Alpha Capricornids meteor shower will take place from as early as July the 15th and continue until around August the 10th. The meteor shower has infrequent but relatively bright meteors and even some fireballs. It's generated as the Earth passes through a debris trail left by the comet 169P NEAT, which was originally identified as the asteroid 2002 EX12. However, it was shown to be weakly active during perihelion and was then reclassified as a comet. The meteor shower was created about 3,500 to 5,000 years ago, when about half of the parent body disintegrated and fell into dust. The cloud eventually evolved into Earth's orbit, causing a shower with peak rates of about 5 meteors an hour and some outbursts of bright flaring comets, radiating out from the constellation Capricorn towards the south. The bulk of the comet's debris won't be in Earth's path until the 24th century, by which time the Alpha Capricornids are expected to become a major annual meteor storm, stronger than any current annual shower. Jonathan Nally, the editor of Australian Sky and Telescope magazine, joins us now for the rest of our tour of the July night skies.
G'day, Stuart. Yeah, well, July night sky, it's the middle of winter down here in the southern hemisphere, middle of summer for the fortunate people up in the northern part of the planet where the temperatures are very nice and it's bright sunlight and everything, but down here it's cold and a bit dark. But that's good. Dark is good for stargazing. So if you go out in the evening, and if you've never seen it, this is a great time of the year actually to go out and spot the Southern Cross because it's nice and high in the sky down due south. Just look straight down south and look up and you'll see the Southern Cross there standing almost upright. Now, the cross is like a kite shape. It's not like a cross, like a plus symbol. It's a kite shape, and it's standing
crucifix.
Almost exactly upright. Its correct name is crux, or you could pronounce it crux, so like a crucifix. It's that sort of shape, yeah. So if you have dark enough skies, see if you can just see a large dark area next to the Southern Cross. This is called the Coal-Sack Nebula, and it's a giant cloud of dust and gas out there in space that's blocking the light from the background stars, so it seems to be a hole in space. But you do need to be under some pretty dark skies to see that and have your eyes well dark adapted, so don't just go out after watching the telly and expect to see it. Give yourself 20 or 30 minutes for your eyes to become adjusted to the darkness, and you should be able to see the Coal-Sack Nebula. It's really quite spectacular when you see it standing out there in the middle of the Milky Way. Now, just off one corner of the Southern Cross is a lovely little cluster of stars called the Jewel Box. It gets its name from the range of colours of the stars it contains. To see it, you'll need at least a pair of binoculars, but even a small pair of binoculars will show you the Jewel Box, and a telescope will give you an even better view. It's a really beautiful little cluster of stars. To the left of the Southern Cross, there are two bright stars called the Two Pointers, so-called because if you draw a line between them and extend it further on, points more or less to the Southern Cross. And we've spoken about these many times on the program. The 2 pointers are Alpha Centauri and Beta Centauri. And we've often spoken on the program about Alpha Centauri and how it's at least a double star system and probably a triple star system if you include the tiny star Proxima Centauri that's some distance away and is in fact the nearest star to our solar system. But Beta Centauri itself, the neighbour, it's a triple star system too. It's got three stars that are pretty much the same kind of star, but to the naked eye it just looks like one star. But it is, when you combine the light of the three of them together, it looks like one star, and it's the 11th brightest star in the entire night sky. We've got quite a few of the bright stars down in the southern part of the sky that we can see.
We're lucky like that, aren't we? The southern hemisphere skies have most of the bright stars in the sky are visible from here.
It's got the majority of the really bright ones, yes. So we're very fortunate. I mean, you can see many of those from the northern hemisphere as well, but of course they're easier to see down south here because they're nice and high. And speaking of high overhead, as seen from southern and mid-latitude this time of the year, are some fantastic constellations such as Scorpius and Sagittarius. Now, Scorpius, the Scorpion, is one of the few constellations whose stars really do join up to accurately reflect its name. If you do a join the dots affair with the stars, it really does look like a scorpion. You see the pincers out the front and then the body and then this big long curved tail with a sting at the end of it. It's really quite spectacular when you finally see it in the sky. It's quite a large constellation, so you've got to sort of stand back and take a big wide view and suddenly, oh, there it is right there. But Sagittarius, its next door neighbour, is named after the archer, Sagittarius the archer. It doesn't really look like someone holding a bow and arrow, at least not to me, but it does have a better claim to fame because when we look in the direction of Sagittarius, we're looking into the heart of our Milky Way galaxy. About 26,000 light years away, in the direction of the western part of Sagittarius, lies the core of our galaxy, the Milky Way, where a giant black hole lives. So 26,000 light years, that's a good distance for a black hole to be. You wouldn't want it very, very close. It can stay where it is, thank you very much, and it's gobbling up lots of stuff all the time.
4.3 million times the mass of our sun. And luckily it's quiet at the moment, although there are those Fermi bubbles to just give us a little bit of proof that it has had a meal recently.
In the northern half of the sky, as seen from Australia or New Zealand, you'll see a few bright stars. There's one called Spica, which is the brightest star in the constellation of Virgo. And there's another one, a reddish sort of coloured one, called Arcturus, which is the brightest star in the constellation of Boötes. That's not a constellation most people are familiar with, Boötes. It's spelled B-O-O-T-E-S, and it means the herdsman or the ploughman. Arcturus, the brightest star in Boötes, is the fourth brightest star in the night sky. And Spica, the other one I mentioned in Virgo, it's the 16th brightest star in the night sky. So there's quite a few bright stars around at the moment. Now let's look at the planets for July. Mercury begins the month out of view behind the sun, but give it a couple of weeks and it will swing around in its orbit and then come up above our western horizon after sunset in the second half of July. In the same area, you'll be able to see Venus and Mars. In fact, for most of the month, these three planets will be fairly close to each other in the post-sunset western sky. Venus will be the big bright white one, Mars will be the dimmer reddish-orange one, and Mercury, the much smaller, intense white one. So they'll be pretty easy to spot because they'll be all close together. If you want to see Jupiter, you're going to have to stay up well past midnight or get up early in the morning this month because it's rising at about 2 a.m. at the start of the month. You'll be able to spot it quite easily, though, because it's a big, bright light in the eastern sky. It looks like a big, bright star So it's pretty easy to distinguish it from everything else around it. And finally, Saturn. Saturn's very easy to see in the eastern sky at the moment after sunset, because next month it's going to reach the stage that astronomers call opposition. This is when the Sun and one of the outer planets, like Jupiter, Saturn, Uranus, that sort of thing, the Sun and one of those are in opposite directions as seen from Earth. So the Sun's that way and the planet is 180 degrees that way. This is the best time for observation because it means that when the Sun is setting in the west, the planet is rising in the east, and therefore you've got all night through till dawn to get your telescope out or your binoculars or just the naked eye and have a good look at that planet, weather permitting. So, and it's also around about the time when a planet, an outer planet, is at its closest to the Earth too. So you get the benefit of that as well. So next month, Saturn's going to be the planet of the month. And that, Stuart, is the night sky for July.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
A lifetime of hard work, children laughing in the kitchen, family photos on a restaurant wall, a legacy that lives on. It all comes from the power of a conversation, like the one Tommy Hall had with First Horizon Bank about taking over his father's Charleston-based restaurant business. Now the table is set for a whole new generation. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy. First Horizon Bank, member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.